All right. So, hello, grade 12s. This is Mr. Musklow. And as I've been telling my other classes, I've become a little bit of a YouTuber, I suppose, because this is actually a YouTube video. Um, Normally, I wouldn't do this if I was away. I wouldn't post videos of me explaining things in normal circumstances if I was away from school. But just with the circumstances with me isolating, I thought it might be helpful for me to just record me explaining question 1A on the assignment because a couple of students were asking me about 1A, basically how to approach the question. Okay, and I thought I'd just make YouTube videos because the videos are just kind of easily accessible on YouTube. So let's talk about question 1A on this Unit 5 quantum physics assignment. So I'll just scroll down here. All right, so question 1 says a laser pointer has a power of 5.0 milliwatts, meaning that it emits 0.005 joules of light energy every second. The light from the laser has a wavelength of 650 nanometers. And then A asks to calculate the number of photons that the laser emits every second. Now, you might have found that there isn't really a question like this in the textbook. And that's because I actually made this question up, basically. I quite like it because it kind of gets to the heart of what photons actually are. So in this problem, we're told that our laser emits 0.005 joules of light energy every second. And we're asked to calculate the number of photons that the laser emits every second. Now, what is a photon exactly? Well, in the lesson where we talked about photons for the first time, we learned about photons being little packets of energy, basically, is how you can think of them. They're little packets of energy. These little packets of energy have a frequency, which is kind of strange, but you kind of have to accept this idea in order to explain the photoelectric effect. And in particular, we know how to calculate the amount of energy that these little packets have. So I'll write down the equation that should hopefully look familiar by now. Okay, so the energy of the photon is given by H times F. So E is the energy of our photon. H is Planck's constant. It's a very, very small number. And then F is the frequency of the photon. Okay, and so our photon, again, it's just a packet of energy. The amount of energy in that packet is given by this equation. Now, in this problem, we aren't given the frequency exactly, but we are given the wavelength. And so if you're given the wavelength, you can determine what the frequency would be for the photons. So once you find the frequency, you can just multiply it by Planck's constant h to find the energy of each of these little packets. Now, once you've found the energy of these packets, it's then just a matter of determining how many of these packets would be needed to create a total of 0.005 joules of light energy. Okay, so that's the basic approach in the problem. Now, I'll just say that a photon has a very, very small amount of energy. So if we're thinking of photons as being little packets of energy, these are very, very small packets of energy. Planck's constant h, you'll remember, is a very, very small number. It's, I think, 6.63 times 10 to the minus 34 joule seconds. So it's a very, very, very small number. And that means, therefore, that these packets have a very, very small amount of energy in them. So you're going to need a lot of these packets in order to make a total of 0.005 joules of light energy. So I'm just making this comment to say that the answer you get for 1A should be a very, very large number. It takes a lot of photons to make up 0.0050 joules because each individual photon has a very small amount of energy. Okay, and so I think it was question 1A that students were struggling with in particular. I don't think 1B was as much of a problem. So I'll just leave it there. This would be the point in my explanation where I would ask students if they have any questions, but I can't really do that because this is a pre-recorded video. So if you have any questions, feel free to just send them to me and I'll get back to you. But yeah, I just wanted to include this video to just hopefully clear up what question 1A is all about. So hopefully that's helpful.